Patient.
Oh, did you enter in the information for?
Yeah, we're good.
The restreamer.
Yeah, yeah, we're live here on X.
Okay, you changed the text.
Yeah. Okay, cool. Well, welcome everyone. We'll get going here. This is our ETH Vancouver weekly meetup. It hasn't been so weekly recently, but a lot of us have been away and we're trying to get back into it. So welcome, and yeah, good to have you guys here. This week, since a few of us were at DEVCON for a little bit, and we wanted to kind of recap what we saw there, give an overview on like what the Ethereum developer community kind of feels like right now, and maybe take a look at some talks. But yeah, I don't know. It's kind of a loose schedule today, so feel free to hop in if you have questions about what DevCon was like or anything in general. We can hop into that. David, actually, if you don't mind setting up some of the mics, we can pass them around if that works. But yeah, okay. So DevCon was pretty interesting. Don't really know too much to say about it, honestly. But there was a lot of people building. Like, it was a huge event. I think there was 12,000 people there. The opening talks and everything were kind of crazy. But yeah, probably the biggest event that I've been to for Ethereum, which is pretty cool. There was like a lot of people talking. It was kind of starting to become bullish again after a long bearish time. But yeah, there was pretty heavy. These kind of conferences are pretty heavy on cryptography. So like 0x Park was a big company there, as well as the Ethereum Foundation, of course. But yeah, I thought a lot of those were more interesting to me, as I'm pretty interested in the cryptography side of things. But there was all sorts of stuff, like a lot of account abstraction stuff, a lot of core protocol. Justin Drake did a talk on updates to the core protocol that he's kind of proposing. So we'll take a look at that one for sure. And yeah, it was pretty interesting. That was probably the most hyped one. So maybe we can just like go ahead and watch that one if you guys are down. It was very hyped on Twitter, and so the room was packed. And we'll see. Can we get audio through this too? Oh, one sec. Yeah, I'm not shooting audio out of here, so let's see. This might work. Yeah. Oh, is that possible? Okay. We gotta go through here.
So the wait is almost over.
Are we able to turn up
the thing that I've been working on for almost all of this year is called the beam chain.
Really quiet. I'll try and talk over it.
So,
so yeah, it was
the beam chain is a proposed redesign of the consensus layer that incorporates all of the latest and from the research roadmap. And the goal is to try and transition in a safe and fast manner from the beacon chain that we have today to this beam chain, which is much, much closer to the final design of Ethereum. Now, before I share more information, I have two disclosures, disclaimers. Disclaimer number one is that this is just a proposal. This is my proposal, and the proposal will only go forward if there is rough consensus with it going forward. And the second disclaimer is that there is no new token, there is no new network, and we're reusing the same ticker. And Vitalik was very, very clear as to what this ticker is. Now, in the rest of this talk, I want to take what may sound like a totally crazy idea and convince you that actually it's maybe not so crazy, that it might be a reasonable proposal to put on the table to completely redesign the consensus layer. And first, I want to tell you a little bit more about the beam chain and what the big picture vision is all about. So the scope of the beam chain is specifically the consensus layer, and I'm excluding the data layer with the blobs and the execution layer with the EVM. And the reason is that the blobs and the EVM are directly consumed by applications, and there is a need to be forward compatible. And so the opportunity to modify these two layers is rather limited. On the other hand, the consensus layer is not directly consumed by applications, and so there's a big opportunity to shake things up a little bit there. Now, why am I proposing now to do this massive redesign of the consensus layer? And it basically boils down to the fact that the beacon chain is kind of old. The spec was frozen 5 years ago, and in those 5 years, so much has happened. In particular, we have a much better understanding of MEV. 5 years ago, we were extremely naive when it comes to MEV, and since then, we've seen the market really blossom and grow. And we also have a much better understanding of mechanisms that can help us mitigate the negative externalities of MEV. Secondly, from an engineering standpoint, we have this wonderfully powerful technology called SNARKs, where there's been plenty of breakthroughs. In particular, we've seen SNARKs become orders of magnitude faster over the last 5 years, and we've seen the advent of ZKVMs. ZKVMs are amazing technology that allows any programmer in the world to make use of this very powerful technology without having to be an expert in cryptography or in SNARKs. And then finally, with the benefit of hindsight, we now know what the mistakes we made with the beacon chain. And we have a bunch of technical debt which is extremely sticky and tends to pile on over time. And maybe now we have an opportunity to clear this technical debt. So I'm suggesting putting the greatest and latest of the consensus layer roadmap in the beam chain. So I guess it might be worth spending a little bit of time looking at what exactly is in the consensus layer roadmap. There's basically 9 different items, and I've categorized them in 3 different buckets: block production, staking, and cryptography. So the block production has to do with MEV. Right now, we have a lot of centralization at the builder and relay level. And one of the things that we want to do is have inclusion lists that dramatically improve censorship resistance. Once we have censorship resistance with inclusion lists, we'll be in a position where we can cleanly decouple the validators from the block production pipeline. And this is called attester-proposer separation, and there's ideas like execution auctions. And then the final item here in the block production bucket is faster slots. Maybe we can take the 12-second slots that we have right now and shrink them, all while preserving the invariant that if you are on a home internet connection, you can participate as a validator, as a first-class citizen, even if you are in Australia with a high latency internet connection. Second bucket is staking. The researchers, I think, have come to consensus, broadly speaking, that the current issuance curve is kind of broken, and that there is an opportunity to improve the health and long-term outcomes of Ethereum by changing it. The second item in the roadmap here under the staking bucket is this idea of dramatically reducing the total amount of ETH to become a validator, from 32 ETH down to just 1 ETH. And there's ideas like Orbit that have been circulating around recently. And then finally, this is an idea that has happened, that has been talked about for many years, is single slot finality. Can we dramatically accelerate the process of Ethereum gaining finality? And then the final bucket has 2 big ticket items. Number 1, can we snarkify the whole of the consensus layer in real time using reasonable hardware? And then finally, can we make the cryptography that is securing Ethereum sustainable for the next decades and centuries and make it post-quantum secure? Now, the coloring here is meant to suggest whether or not the item in the roadmap can be done easily, incrementally, or whether it can't. So the 4 green items here in the top left corner are items that I think can be done and should be done in incremental forks on the beacon chain. But then when we get rid of those, we're left with big-ticket items, the red items, that I would argue are best done in a more holistic way. So take chain snarkification, for example. In order to achieve real-time proving of the beacon chain with reasonable hardware, we're going to need to change the hash functions. We're going to need to change the signatures, the way that we serialize and Merkleize the state. And this is a massive change to the beacon chain. And so maybe there's an opportunity, well, if we were to make such a change, to change other things at the same time. And then a similar thing can be said for the bottom two red boxes, faster slots and faster finality. The truth is that 5 years ago, our mindset was security first when we designed the beacon chain. And performance was not really a main consideration. And with the benefit of hindsight, we found that there are designs that preserve all of the security that we want and at the same time pick some of the low-hanging fruit that is available to us to improve performance. Okay, so this slide here is trying to show the mapping from the consensus layer roadmap that I showed you and Vitalik's broader roadmap. We have some items that are classified under the merge, some that are under the scourge, and then a couple that are under the verge and the splurge. And the whole point of this slide is to communicate the fact that the beam chain is not about changing the roadmap more so than it is about identifying a specific subset of that roadmap and accelerating it and putting a mimetic wrapper around it. Now, one thing that is new in the consensus layer roadmap here is the faster slots. And the reason is that the discussion around faster slots has happened this year in 2024, but Vitalik's roadmap diagram was only last updated in 2023. Now, in addition to being able to potentially accelerate these big-ticket items, there's a lot of technical debt that I mentioned that can be cleared out. If we have single-slot finality, we no longer need epochs. We can just have slots. The deposit contract that we have right now is kind of crazy, and it's a remnant of the merge. And things like the sync committee is infrastructure that we won't need going forward if we have real-time snarkification of the beacon chain. And the list goes on and on and on. And this is an opportunity, as I mentioned, to just clean it up all in one go. And if you're interested in learning more about some of these beacon chain mistakes, last year I did a whole talk where I talked about 20 or so different mistakes that we made in the beacon chain design. Okay, so this is the big picture view of how we have done upgrades to the consensus layer since Genesis. So in the bottom left here, you can see we did Genesis in 2020, and since then, it's been an extremely regular pattern. Every single year, we've had a new fork, and every time we had a fork, we made one incremental change to the consensus layer. So in 2021, we added sync committees. In 2022, we did the merge. In 2023, we added withdrawals. And then proto-danksharding. And soon, in 2025, we're going to increase the max effective balance. Now, what I expect will happen is that over the coming years, we will continue doing these incremental forks, and we will be picking up the low-hanging fruit that was marked as green bubbles in the roadmap, in the top left corner of the roadmap. But then we're going to kind of hit a wall. And the reason is that once we've picked all of the low-hanging fruit, we'll be left with all of the big-ticket items that are much more difficult to do in an incremental fashion. And this is where the beam fork happened. The beam fork is an opportunity to have a quantum leap forward in terms of upgrading the consensus layer all in one go. And one way to think about the beam fork is as a batching opportunity. we're batching multiple upgrades into one single fork, and this has benefits both technically and from a governance standpoint. And one way to think about this batching opportunity is as ossification accelerationism. This might sound like an oxymoron, but the basic idea is that we want Ethereum to go in maintenance mode as soon as possible. And right now there's this tension because we know that there's these big ticket items that require a fundamental re-architecturing of Ethereum, and the more we drag it along, the further Ethereum will be in a position where it can comfortably ossify. Okay, part 2. I'm going to try and highlight some of the technology that is going into the proposed Beam chain. And the way that I would frame this is basically in eras of Ethereum consensus. Initially, we had the proof of work era of Ethereum consensus, and then we moved to proof of stake. And now we're potentially entering this ZK era of Ethereum consensus. And in the ZK era, we would be making heavy use of snarks as a technology. So one place where we'll be making use of snarks is snarkifying the entire Beam chain, the entire consensus layer. And this is where the ZK VMs become extremely handy. So imagine that you have implementations of the Beam chain in various high-level languages, in Rust, in Go, for example. What you can do is compile these high-level languages down to bytecode that the ZK VMs will understand, and get snarkification without having to worry about the details of the snarkification process. Now, one thing that I do want to highlight is that the only part that needs to be snarkified is what's called the state transition function, which is basically the crystalline core of what it means to be a consensus client. All of the infrastructure surrounding the state transition function, for example, the networking or the syncing or the caching optimizations or the fork choice rule, none of that has to be snarkified. And ultimately, the state transition function is a small subset of what it takes to build a client. And what we've seen recently in the last couple years is RISC-V become the de facto industry standard for these ZK VMs. So RISC-V is an instruction set, and basically you can take high-level code and compile it down to RISC-V. And we've seen 7 different companies provide these RISC-V ZK VMs. You may have heard of RISC-0 and SP1, and the list goes on and on. Now, one little side note here is that this exact technology, which is extremely powerful, can also be used at the execution layer for the EVM. But that is a completely different story to the Beam chain story. It's one which is extremely exciting because it means that we can dramatically increase the gas limit, as well as vertically scale Ethereum layer 1. But this is going to have to be for a different talk. The other place where we make heavy use of snarks in the Beam chain is with aggregatable signatures. We want to have post-quantum aggregatable signatures. And the proposal here is to use hash functions. Hash functions are post-quantum secure, and you can use that as a basic building block to build your cryptography. So we would have hash-based signatures that are produced by the validators, by the attesters, and we would also have hash-based snarks where you can take many thousands of signatures and compress them down to just one proof. And with these two combined, you get a hash-based post-quantum aggregatable scheme that could be used for Ethereum. And one little nice detail is that this aggregatable scheme is infinitely recursively aggregatable. So you can take aggregates of aggregates of aggregates, which is something that we can't really do today with BLS. So it's much more flexible. And the reason why I have this proposal here today is because in the last few months, the progress in performance of snarkifying hash functions has gone through the absolute roof. So for those who are in the know, we're now able to prove on a laptop. So this benchmark here was done on a laptop CPU, a MacBook Pro. we're now able to prove 2 million hashes per second, which is an astounding amount of hashes per second. And this means that this hash-based proposal has the potential of being extremely performant for the beam chain. Now, in addition to the very powerful ZK VMs and SNARKs that we would be using, I also want to highlight that to a large extent, we would also be reusing existing infrastructure. So the networking libraries, libp2p, the serialization libraries, simple serialize, all of that can be reused as is today. Same thing for the PySpec. PySpec is the framework that we use to write the formal specification, the Python specification, and the unit tests, and we can also reuse Protocol Guild, all of which is infrastructure that didn't really exist when we started with the beacon chain. And the same thing can be said about teams. When we started the process of the beacon chain, there was no team, there was no consensus client teams. So the 5 consensus client teams that we have today, this is manpower that can be reused and doesn't have to be rebuilt. And in addition to that, we have dedicated teams that were put in place for the merge, for example, EthPanda Ops, which does DevOps, and the security team within the Ethereum Foundation. And I also want to give a shout out to...
I might cut it off there. He goes a little bit more into that and the just the timeline for things. But essentially, what does this mean? I mean, I'm not Justin Drake. I don't understand it fully. But some of the big things here are the like the staking smaller validators. If you could validate with just 1 ETH, it's a lot easier to kind of participate in the network. Also, the snarkification. If you're not aware, like ZK basically allows you to do a proof that takes quite a while, but verifying that proof is very quick. So in the context of the consensus layer, if you can, let's say you propose a block and you generate a proof that it was a valid state transition. Where was it? So all these accounts sign these transactions. We're going to send this much ETH to this account. We're going to change the storage on all these contracts. If you can generate a proof and then just send that to other nodes to validate it, if they're able to just verify it way faster than re-executing it, this opens up the door for like light clients. So if you want to run a node on your phone, you still need a good internet, and the networking is maybe the difficulty there. However, you don't need a large computer in order to validate the network. So it kind of reduces that quite a bit, which is a very exciting part, as well as the quantum security, of course, which is maybe not so exciting, but something that we kind of need to be thinking about. Those were kind of my 2 takeaways that were the most exciting for me. The kind of controversy here was because it was very hyped up and everybody was like, okay, well, that's cool, but not super exciting. I think it's still very exciting. The other thing, though, was that the timeline is quite long, which people were not happy about. If we have to wait 5 years for this to come out, then that's not that great. Yeah. Yeah. We'll see. Well, because this is just Justin's proposal. So because the Ethereum protocol is so distributed, it takes a while to kind of decide what to actually do, and what to focus on. And there are some people that are also like, oh, well, like, why is Justin Drake just all of a sudden saying that everybody should do this? It's pretty clear that this is his proposal for what maybe we should do, and trying to get people on board with pilling them. But yeah, do you guys have any questions or about his talk? I can try and answer them, or anything in this realm. Cool. We'll just continue then. We can keep going into other things I found kind of interesting. We don't have to watch the full talks. But one of the ones that I thought was really cool was the, I'm actually not sure. Yeah. So I'm not sure if he's actually the founder or if he's just the CEO. But essentially, EVE Online is known for being an incredibly like complex economic system that's really like you have to put a lot of time into it. But it's this huge economy that like competes with countries. And so what they're doing is they're actually, yes, the space MMO. And so what they're doing is they want to make sure that this lasts forever, so that even if CCP Games, which are the developers, if they are no longer at some point, they want the game to continue and the economy to continue. And another thing that they want is on and off ramping, which is really cool. Like EVE is such a big game, and it's really cool to see that they're looking at Ethereum for deploying their next project. We can take a quick look at this if you guys want. I thought it was pretty interesting. Sorry? Yeah, I was just gonna turn off my mic.
Thank you. Okay, I come from CCP. It's a company founded almost 30 years ago in Iceland, and this is our mission. We want to create virtual worlds more meaningful than real life. This is probably something that's going to take 100 years, and it's very provocative, but I assure you, we actually believe it's a good thing. If you were here for Justin's talk just earlier, he was there for digital civilization. We have created like what could be a prototype of maybe not like a civilization scale, digital civilization. It's more like a digital nation of sorts. It's a game we released 21 years ago. It's called EVE Online. Currently, there are about like 1 million characters playing it. It has a lot of transactions. And it is actually the first game built on top of a database, which was very controversial at the time. Like I said, we come from Iceland. Iceland is a country that just recently has more people than sheep. So in our sort of coordinate system, 1 million people is a lot. It's almost 3 times the people that live in our country. We also made other games over the years, but 60 million people have played even other games. This is the first version of EVE Online released summer 2000. This is what it looks like today. This is a picture of our Guinness World Record of the biggest spaceship soup ever created. This is basically an all-out fight of 8,000 people. We have spent updating the game over these 21 years. So about like 4,000 people have spent 21 years to build on top of this basics. We actually released yesterday what is the 50th big update to EVE Online. So if you want to check that out, now's the time. But the most important building that happens in EVE Online is that players, it's a sandbox, you need to build stuff. All the infrastructure in EVE Online is built by players. If I aggregate these 21 years, the millions of people that have played, etc., it is enough to build 10 pyramids of Giza. Nobody, of course, knows how the pyramid was built, but by some estimation, it would be that. And that is really why we are the most excited about, the building that happens in this virtual sandbox and how we can enhance that. Mainstream media has kind of adopted EVE Online almost like a virtual nation. You see war reporting from BBC, from Yahoo, etc., where people are sort of delivering news from this digital civilization as if it's happening for real. We've also had riots, we've had economic collapses, we have had all the things that civilizations should have. This is storied. The 3rd history book is now being written, but you can buy the other 2. If you want to really, really go down the rabbit hole, I recommend this YouTube series, Down the Rabbit Hole. It's 6 hours, very good for a long play night. We're obsessing about like physical things because it's so virtual. Here's a little pyramid we're building on the shores of Reykjavik. We added a 2nd layer on year 20. So by year 30, we will have a 3rd layer. And by year 100, we'll have a pyramid on the shores of Iceland. So there's a lot that goes on with EVE Online under the hood, and it's shockingly not very technical. There's an aspect to EVE we call the EVE effect, which is combined of two things. It's the friends you make, and it's the skill you gained. If you survey EVE players, 73% of EVE players claim they've made a new lifetime friend from EVE Online. It's to a point where this is the meme. It's a spaceship game, but the best ship in EVE Online is the friendship. This is a big topic. As we all know by now, loneliness is a mega issue. It's the biggest health crisis in the world, vastly underreported. We have discovered a formula of how you make a friend. We're mega nerds. We didn't make the formula. It's known in psychology: proximity, frequency, duration, and intensity. So EVE is very known for being super hardcore, super hard, death penalty, etc. And it's actually this hardship that creates the friendship. So when you survey EVE players, why have you played this game for 21 years? It is usually a story about a devastating loss where people had friends to pull them back from it, or they gained friends to doing that. And if we ask players, how do you self-identify? You would think PvP, sandbox, it would be like killing and building and exploring. No, it's actually helping others. Turns out when you make PvP capitalistic death hellscape, there's just a lot of people that need help. And again, if we survey players, the people that like to help others, they enjoy EVE Online the most. Very interesting. Often the friendships elevate to various other relationships. Here's me marrying people about a decade ago. Now the space pope takes care of the marrying. This is what governance looks like in EVE Online. This is a Council of Stellar Management meeting. This is a democratically elected council of players. You see me there squirming at the end. The guy talking here has PhD in AI. The next guy to him has PhD in how mice make new memories. Social organizations are a huge thing in EVE Online. Here are the 3 top alliances. They are the size of the UK military, just to kind of compare social organizations. EVE is obviously known for this. It's massive alliances. Because to kind of go anywhere in EVE Online, not only is it the friendship, it is the scale of the social organization that you belong to. EVE is also arisen to be more than a game. With an API we created, massive amount of things have created that, and we believe EVE is going to go on forever. That brings us to eFrontier, which is a new experience we are creating, where we are going to get closer to the digital civilization Justin was talking about earlier. And we hear here a little video that is going to take you through like a brief introduction of that. If it plays.
It always happens.
Yeah.
Welcome Awakened. I'm CCP Overload, and I'm excited to showcase what we've been building to you today. Before we begin, please note that all footage shown is under development and not fully representative of the final version of eFrontier at launch. So, eFrontier, what is it? At its heart, eFrontier is a space survival simulation, an online multiplayer survival sandbox where players are locked in constant conflict within a region of space known as the Frontier. The Frontier is a place of decay and danger, a shattered post-apocalyptic landscape covered with mysterious ruins and infested by hostile AI. At its center sits the Trinary, 3 hypermassive black holes bound in a dance macabre, perpetually shaping the fabric of the galaxy and acting as the bedrock for the endless cosmic turmoil that players will try to survive within. The Frontier is a dark and dangerous place. Ancient structures from a long-gone civilization crumble and rot, while riders, pilots who roam the Frontier, scour them for resources. We are creating a deep next-generation and player-driven sandbox. eFrontier will give players the power to shape the experience as they see fit. With an openly programmable world, players will be able to configure in-game structures to their needs, giving third-party developers complete freedom to unleash their creativity. This also extends to the economy. Players can create their own currencies, establish private markets, and convert their assets, services, and reputation into real-world value. eFrontier places a focus on the now, with moment-to-moment decision-making having meaning and depth. Strategic combat has tactical flexibility, positioning and environmental awareness matters. With occlusion, you are only aware of what you can see before you. Dodge incoming fire, use celestial bodies as cover and execute maneuvers to outflank your opponents. Will you be the defenseless miner, unaware of the hostile ship approaching from behind an asteroid? Or will you be their friend, hiding in wait to counterattack a common foe? As a newly awakened rider, you'll be thrown into a desperate world full of death and suffering, but also ripe with potential. In a vast galaxy of over 20,000 star systems, your future is yours to forge.
I told them.
Will you become an industrial powerhouse?
Okay, so the journey to this point has not been short. I've here journaled.
Cool. Yeah, so I thought I got really excited about this because I've heard a lot about Eve. I've never played it because it takes hours and hours and hours and hours to just get started. But it is a huge economy, and it's a very famous game. It's been around for a long, long time. And it's really cool to see a game like this realize their difficulties and how a blockchain can actually solve it and adapt to what they want to solve. So this is, what is this name? Sorry, this is Justin Gilbert. He's one of the founders of Zero X Park, and they created a game called Dark Forest. It was kind of in the early days, 2018, yeah, a little while ago. A game on Ethereum that essentially is a fog of war game that's a very kind of low scale version of this. And they've developed this this tooling called MUD, which allows you to define these rules and physics essentially for a world and let players determine how they want to use that in order to play the game. So they're working together essentially to bring this next Eve version to fruition and allow for a few big things, which is off-ramping from an economy at this scale or buying into it, and also making it essentially last forever. Yeah. Yeah. Cool. Any questions about that or things around there? Yeah, actually, we can go through that if you want. Yeah, you want to grab a mic here at the front?
My question is if every player can create their own currency, how would that work in terms of the adoption of that currency? How would the players accept another player's currency as the legal tender or something? Yeah,
it's right now. Would you accept Rismus as legal tender or
or Pepe coin?
Yeah, Pepe or whatever. Yeah, exactly. It's like our real world economy, right? Who is your currency worth something? You need to choose that yourself. Yeah, I think actually this goes into... No, I think this is their old architecture. Here, okay, we can take a look at this.
Where are we at with this whole digital physics, right? So we're following a barbell strategy. On the left, we're investing in a lot of time in very core systems to formalize and secure the whole world, whether it's key assets, markets, players' identity in the world, etc. On the right, we invest a lot of time into making sure third-party developers can tap into the world itself, right? Through these structures in space you saw in the video called smart assemblies. People can build warp gates, smart storage units, smart turrets. And the way it works is it's not like we put together these parameterized program, almost like roller coaster rides in a theme park. Players actually tap into the primitives in order to build this themselves, right? It's on them to figure out what they can do with the rules of the world in order to rebuild that broken world. And in the center, we have a bunch of really annoying stuff that we don't know how exactly we're going to go towards digital physics, but we're making progress there. Like things that require very low latency, things that require a lot of information asymmetry. Some of the markets today are still there. And over time, we kind of like want to squeeze the box in the middle and land things that are on the left or on the right. You could imagine in a short future, everything but space travel and combat remains in this middle category. And with a lot of effort in cryptography, both sides should meet, bringing us one step closer to Eve forever. Okay, so I'm seeing I don't have that much time left, so I will give a few very quick examples of this via negativa and what happens when you do that. So in EVE Online, which is a different game, but it's useful to refer to it, CCP Games built this very complicated contract system for things to happen in the world, right? And so instead what you can do is, if you let people check that stuff happened and you let them do asset transfers, they can now build whatever contracts they want and make them as exotic as they want. Like CCP cannot just delete like 30,000 lines of C++, something like that, just a ton of code just by doing that. Similarly, in EVE Online, there's a bunch of like player organization systems, like corporations. If you let people identify players, control other subsystems, you can now build whatever organization system you want. You can just like remove all that code as well. Same with markets. But it also enables you to do things you couldn't do before. Players have been asking for being able to put their own structure in space, that they kind of like program to do whatever they want. And that's really hard to do if all you have access to is these like cookie cutter parameterized programs, which is what most people do these days when they build online worlds. And so now in Frontier, you have these smart assemblies that people can, where they can essentially tap into these like very low-level primitives, like attack, transfer items, warp, in order to build essentially whatever they want. So Frontier's physics is built on mud. When people were asking earlier, what does XeroXproc do concretely to approach the vision I was laying down? Well, that's the kind of stuff we do. You know, we think virtual worlds are actually like heavily underrated and extremely important when it comes to our transition towards digital civilization. And so a company in the XeroXproc ecosystem has been building a framework for building very large application on Ethereum with a lot of state and where many participants can kind of like tap into what's going on. And Frontier's asset, logic, and state and third-party extensions are all centralized in one mud deployment. So the quick 101 is there's a shared mud world where CCP Games build the core physics and a bunch of core data structures, and then third party can come in and deploy within this world things like, you know, like new mini games or new mission and reward system. All of this logic is centralized into one big system that can coexist through like these rules that are enforced across first party and third party. And when you put the lens of like, well, what happened beyond the blockchain, what we have is we have the EVE world that is its own source of truth, and on the right we have all the stuff that is still in gray in the diagram I showed you earlier that runs on these solar system servers. The state of the chain is reflected in a chain database. The game database is the good old world database that you guys put together 20 years ago. And what we want to do is we kind of like want to reduce the size of the game database and increases the amount of state on the chain. And over time, we're going to effectively do a progressive transfer of authority from the server to the chain over the next few years, right? So with that, I'll pass it back to Hilmar. Thank you.
Okay. Yeah, so it talks a little bit about it. From what I understand, MUD, they don't actually mention it in their docs, but I think they use essentially ZK. So you can create this game of physics, or he said actually that they use an Oracle, so maybe they don't use ZK. But you can create these physics rules that would then, when you go to make an action on chain, we can verify that it was within that set of rules. So your action or your data that's stored on chain may be very small. It's not like going to store the whole game assets on there. But you're able to just make sure that everything is within check, kind of like creating your own smart contracts for that. I don't know if that gives a little more insight onto. Okay, cool. Any other questions about this or anything in this realm?
Are they building on an L2?
Probably.
Which one?
So, yeah, Dark Forest was initially built on L1, I think. And then they switched over to Gnosis chain, which isn't necessarily an L2, but a high throughput chain. That also kind of aligns with Ethereum as well. But yeah, I don't think you would really want to do this on mainnet. So probably their own L2 or some L2 that wants to host them. Okay, so yeah, we kind of covered. Those were my two largest, the ones that I thought were the most interesting. I have a couple other things starred here. We can kind of see if we want to look at any of these. A lot of these are also lightning talks, so they're just like 7 minutes. We can kind of take a look at those. Let's see, what do we have here? Actually, yeah, if you guys see anything that looks interesting, you can. This one? Okay. Yeah, it's just a 7-minute one, so we can take a look at this.
Yeah, it's working. Okay, cool. So, hello everyone. I'm Giacomo and I work as a software engineer at the PSE team. So, as many of you know, the last few years have seen a huge generational shift in cryptography. We passed from specialized to general purpose cryptography. And this has brought exciting new opportunities for everyone to make it more practical. But this comes at a cost. The cost is that we should navigate lots of jargon and mathematics. And to get the big picture also for people that is experienced in the field, it's pretty hard, like navigating the protocols, primitives, languages, tooling, etc. So today we'll try to do something very difficult to give just an overview, but we will stay really high level, general purpose, in order to understand what the building blocks of programmable cryptography can bring. And we will just focus on the programmable part instead of the cryptography, which is how things work under the hood, because we do not have much time. So, yeah, zero knowledge proof. So at zero knowledge proofs make one party, the prover, able to prove to another party, the verifier, that a statement is true without revealing any information beyond the mere fact of the statement's validity. So you can use this, for example, to prove your age that is above some sort of threshold without saying exactly what your age is. Secure multi-party computation is a set of cryptographic protocols that let multiple parties collaborate together to compute a function providing their inputs, maintaining those inputs for all the computation private. This is useful for use cases like voting, when you have to vote on something and you want to keep your vote private, and you do not want to trust on a third party to count the votes. Then we have FHE, full homomorphic encryption, set of cryptographic tools that enables you to do encrypted computations. What encrypted computation means is that once decrypted, you get a plain text. And this plain text is the same as if it performed the computation on the decrypted data directly. This is ideal for scenarios like outsourcing computation, like running machine learning model without letting the model owner learn about your data. Each of this block is pretty powerful by its own, but they open up fascinating possibilities by combining them. In particular, on trying to solve their own drawbacks. For example, DKP can be seen as an efficient app-specific MPC, but combining them, you can obtain verifying the MPC computation, able to prove that the multi-party computation was performed correctly under some assumption in the key. So instead of just computing, you can also prove from input to output the computation, or you can outsource the computation. So you can rely on other people doing the computation for you. They can be more than one people. And this can enable complex cryptography also in resource-constrained device, because you're not computing by yourself. Another combination, MPC FHE, one of the biggest challenges in FHE is managing the decryption keys. And there are two main approaches. The first one is with MPC distributing the key generation. So you have multiple parties, and they can jointly and manage a single FHE key, where no single party has the ownership of the key. And the multi-key FHE, everyone has a key, and they should combine the key to perform the secure computation. On the other hand, since FHE is just addition, multiplication of ciphertext. You can achieve sum of product of encrypted values. So you can build generic MPC. With ZKP and FHE is the most experimental and is basically trying to tackle two questions. The first one is, how can I trust that the encrypted value was correct under some assumptions, like is a correct BFE ciphertext? Or how can I trust that the computation was done correctly? And all three blocks combined is like, you can combine them, it's technically feasible. We can add ZKey to make verifiable MPC FHE combination. You can add T's, trusted execution environment, to do the ZKey and participate in the MPC FHE, but we are still need to take into consideration that many real world problems can be solved with just one vanilla block, like just ZKey or MPC. And defining resources, constraints, and unique needs of your problem can help you navigate all the space of the solutions and help you to make the right choice. I'm running out of time, so thank you.
Yeah, so that was pretty quick. Yeah, I've spent quite a bit on this myself, on like learning these technologies as well. But yeah, I mean, I could try and just go back over what he said, but I don't know if I'll add too much. These three are kind of definitely big things in programmable cryptography. I would say that they kind of all fit under that umbrella. But yeah, they allow you to do different things. You definitely need more than one of them for some things if you're going to do them. Like you said, MPC is not, you can't necessarily verify that it was done correctly. If you add ZK keys to that, you can do that. There was also Barry Whitehat, which was the previous leader of the PSE. PSE is indistinguishable obfuscation, I think it was called, which is just a new term that everybody's interested in now. But they're not actually sure if it works or not. So there's a bounty up for that as well. What that does is it supposedly kind of hits that holy trinity in just one technology without using all of those technologies. But I've been meaning to go back and look at that. So there's a new one coming. Be ready for that. but yeah. Any questions about ZK, MPC, FHE at all? Cool. Yeah, what else can we look at? I mean, are you guys curious about anything in particular about the ecosystem? Or yeah, Christian, do you have a like?
You mentioned track. Were there any on that topic that you saw that you thought were interesting?
I didn't go to any of those, unfortunately. But let's see if we can get the quick, there might be some quick rundowns in here. Yeah, the opening talk or which one? I think he mainly only did the opening one. Yeah, there was a panel that he was on. I think mostly just panels. I don't know if he did any specific talks himself, other than Ethereum in 30 minutes. The opening talk was pretty interesting. Is part of it. We can watch a quick part of that. I think it's in He's actually in here. It might have been the. I don't know if we want to watch this whole thing unless you guys are down. His roadmap? No, I don't think he really did. I don't know where he stands on it, unless I just missed that. But he talked more about like kind of what we've done to get here, and maybe more like high level of like what Ethereum should become, but none of the technical aspects. Yeah, do you have is there a mic over there?
Hello. Okay. So I'm not a developer or anything. This is kind of over my head here. I'm just curious. So first of all, I guess the whole talk, is it about like this whole conference? Is it mainly about the future of Ethereum?
Yeah. So like because Ethereum ecosystem has gotten so big at this point, there's so many different like routes you can go. You can go with DeFi or real world Ethereum and all these things. But yeah, mainly people talking about what they're building right now, or what they're planning to build in the future and how they want to improve Ethereum. But it's a mix of what's going on right now, as well as like what plans there are for the future.
What do you think that's most promising that you've seen from all these videos or from this conference?
I think like it'll take a while to get there, but the cryptography parts, like we just watched with like Eve online, like I think that was really exciting for me to see a massive game like that, kind of gain adoption and see where the use cases of Ethereum are. Yeah. So there was a lot of onboarding as well.
Is that through like the gaming route, like using games to, or just movies or whatever? Eve would be like a great game to develop.
Because this is a developer conference, so it is mainly focused on developers. But things like that, like the Eve, is a huge onboarding thing. Gaming, also account abstraction is one of the things which Kristen mentioned, which essentially is like you don't want to have to create a wallet with a seed phrase. You want to be able to like create one with your Google account, or whatever. Gasless transactions as well, so that like when you first get your wallet, you don't have to have ETH on there. You can just get going. Applications can pay for your transactions or different like sponsoring things.
Been around for a while though, so it would have been interesting to know sort of like what they were hitting on this time around.
Yeah, that's true. Because yeah, 4337 has been around a while. I honestly didn't see any people like talk about it. Maybe I wasn't at those talks. I think Uniswap might be doing it. So Uniswap is also doing their like Unichain now, which is kind of paired with their wallet. So if you go and make swaps on there, a lot of the difficulty there is like, what do I want to bridge to a chain to make a swap? They're working on account abstraction as well as like chain abstraction. So you don't have to bridge and then swap and then bridge back or whatever. You can put those behind the scenes and essentially just do that without having to notice it. So there was like a lot of UX things that people were talking about, like that, being able to chain abstract or bridge abstract, kind of fix that. And what also, there are issues like that, because how do you know if you're swapping from base to whatever? If you want to be more technical about it, it's hard to know that as well. I don't know if there are any talks specifically at DEVCON about that. And the Uniswap one was at a different event, but yeah.
What's the real world Ethereum, you said?
Real world Ethereum, yeah.
What's that?
Yeah, so there was, I might have had some sort here. Oh, the Frontier. Real world Ethereum is mainly like, what can we use crypto for other than like financial applications or kind of contained ecosystems. Let me see if there are any interesting ones in here.
That's like has to do with like the RWA stuff, like the real assets.
It could. Real world Ethereum could be potentially RWAs. I feel like that does fall under that umbrella. Other things are like voting. So if you use like yeah, for like voting systems, you could use Ethereum or other blockchains in order to like use that technology and make it more secure.
I think the government would use something like that for like a voting agency, or would it just kind of be its own independent?
Yeah.
kind of
So
company or something like that?
yeah. So that's a good question. Is like, would governments actually adopt this? And it's difficult because they have to see what the benefits are, and we have to get to a point where it's actually good for that, being able to do that. There actually was one about where was it? About using the Mexican government created a essentially keys for let me see. Nope, nope. Should start that one. Okay, all right, I can't find it now. There was one talk about the, oh, it was on here? Oh, shoot. Oh, yeah. Yeah, you want to watch this one? It's pretty short.
All right. Thank you for that. It's one of the last talks of the day. We don't have much time, so hope it will be a good one for you guys. Yeah, so my name is Arun. I work with UNICEF. I'm the blockchain lead at the ventures team within the UNICEF Office of Innovation, and we are here to chat with one of our portfolio companies, Statwick, around the supply chain solution that they have worked on and the impact they are creating, along with a partner of ours on how to get these open source digital public goods funded. May I ask you guys to quickly introduce yourselves, starting with Mansi?
Sure. Thanks, Arun. Hi, good evening, everyone. My name is Mansi. I'm the head of product at Statwick. We are a blockchain-based company where we are basically focused on enhancing the transparency and efficiency in the global health public supply chains. What we essentially do is help stakeholders keep a track of all their transactions and give end-to-end visibility in the supply chains.
Thank you, and thank you both for the invitation today. David Casey here, Director of Funding the Commons. Funding the Commons is a community and event series focused around exploring public goods funding mechanisms. And we do conferences, hackathons, open source developer residencies. We just completed one in Chiang Mai last month, and public goods funding experiments, so applied experiments using new mechanisms.
So in case you're wondering what a UNICEF person is doing here, so we have been working with blockchain since 2015. We run something called the UNICEF Venture Fund, where we provide funding for early stage startups such as Statwick that Mansi is working for. And we are also interested in digital public goods. We are part of the Digital Public Goods Alliance, and that's how we got to know David. So hence, here I am. First question to Mansi, could you please maybe talk a bit of the product around the vaccine supply chains, please?
Yeah. So I think the problem, the challenge that we were looking at was twofold. So the first initial issue was around how the supply chains are fragmented, and specifically in the healthcare systems, how they rely on siloed information which do not talk to each other. The other issue was also around product wastage in terms of expiry, counterfeiting, and cold chain failures. So this was like the primary agenda that we wanted to solve firsthand, and have a a unified platform. So that is where we've built a solution called Vaccine Ledger, which typically ensures that every physical asset in the supply chain, we create a digital twin of that. And so from how that works is that from the time of procurement or from the point of manufacturing, and every time the product changes hands, we basically record the journey of products as and how it is passing on. So we help ensure that all these stakeholders are completely aware of where the product is in supply chain right now. And we did also have issues looking around how 30% of the global vaccines were wasted, and there was lack of information even within many organizations who were sending out products to various LMIC countries, but there was lack of visibility whether it's reaching the final beneficiaries or not. So it becomes very important and critical to ensure that the life-saving vaccines and medicines reach to those people, especially in the underdeserved areas. And that's how I think what we're trying to do is leverage blockchain and provide that the whole data in real time for every stakeholder to make informed decision.
That's fantastic. So blockchain here is, of course, used to track every vial of the vaccine, I think, which adds a next layer of traceability and visibility, which all the stakeholders get. And talking of stakeholders, where have you piloted this solution so far?
So we've had a couple of deployments. So we had it both on the private side also and on the public. So we did a couple of deployments in Costa Rica. We had partnership with IDB, Inter-American Development Bank, who actually opened doors for us to help track products within that market. So the major issue at hand was that once the manufacturers send the product, they only have visibility till Panama, and after which there's complete lack of understanding of how is the product moving in the country. So we did make a deployment there, and even during COVID, we were able to track 1 million doses of COVID-19 vaccines, and also the end beneficiaries who were receiving it. And we did have another major deployment with UNICEF. So the way it works is that we have an LTA with UNICEF, so that basically gives us that opportunity to go to multiple countries. We recently just deployed in Bangladesh. So we are ensuring that we are tracking the product from the central procurement level at the country. And there are multiple various stakeholders within the entire ecosystem who are also going to be a part of it. The major challenge I think we did have around was, there were barriers in terms of digital infrastructure. So they did not have enough capabilities that could support, and even in terms of remote locations, right? So there were very, very remote locations where you do not have bandwidth capacity, internet bandwidth capacity. So we did employ a good workaround plan for that, to have an offline mode, which basically helps people record information in real time. So once they have the data connectivity back, they can they don't really have to enter it again. But there were, again, issues with having localization in place. So we did understand that it was going to come up eventually, as in how we, naturally grow to multiple countries. We would have to, have the application available in multiple languages. And how we have also made the whole thing accessible is that it's a combination of both web and mobile app. So the way it works is that the user who was initially recording it manually on a book and pen and paper, he has the access on his mobile app. So all he just has to do is download the app, record the transaction. So there's no double work that he would necessarily have to do. So in that sense, I think what we're also trying to do is have some concept called incentivization for making it easier for people to adopt the application. So that's where I think with UNICEF Bangladesh, what we have done is the demographics are vast there. So we are looking at almost 100,000 million doses of vaccination that we are going to record every year. And that's a huge number. And then we have good 150,000 plus users and wallets that we are going to generate just with UNICEF Bangladesh. The plan is also to like scale up to various other supply chains. So we've had like parallel conversations running with animal vaccines, for nutritional vaccines. So the way it works is that the whole platform has the capability to not just expand within the human vaccine space, but it has like a similar use case in various other dimensions. So it has the potential of creating a good, 5 million wallets in the next coming up year or two. So we're looking at like some potential contracts coming up, hopefully soon.
Thanks a lot for not just highlighting the challenges that you guys had to overcome in a real world use case, but also the kind of impact that could be generated. So she was talking of millions of wallets, and stuff like the offline mode. It gets very real out there. So that is a lifesaver actually, which enables the blockchain to always be in sync. And other things that you mentioned as well. That's actually fantastic. So now I'll switch to David. So as you could see, David, like these guys managed to not just build the tech, but also make it accessible and make it work in the real world. And just in Bangladesh, they'll soon start tracking 100,000 vaccines with thousands of wallets. So for projects such as this, Web3 projects, real world, open source, what would be the sources of funding that they can tap into? Could you please take us through an overview of that?
Yeah, so I think I've always thought that this is a very interesting use case, real world, real-time supply chain tracking. I remember a project from about 6 or 7 years ago, I believe it was called Wabi, that was more focused on food, and there was like a lot of kind of fake ingredients issues, especially in China. I'm not sure what happened to it, but I thought it was a brilliant use case. And it's not like sexy because it's real world and there's not that much to speculate on, but it's actually like really, really useful for millions of people. I think in terms of funding, in crypto we have this kind of phrase of public goods funding, but often what people mean are funding network goods, which are kind of digital public goods, open source.
You can kind of cut it off there if you guys good with that. But yeah, I think another really interesting thing was the amount of like representatives of these companies, like UNICEF was there. Also there was like the founder of Tor gave a talk. Eve, there was a few others as well. And it was really cool just to see that like getting adoption and there are use cases and there is real world Ethereum. But yeah, I think overall it was a pretty interesting conference. I think that a lot of people were kind of excited again. That's a good question. I don't. There was a who was it? EY had a booth. Not a bank. Yeah, consulting. But that was more of a like a bigger kind of web 2 company. No, I don't think so. Let's see if there was any anything under RWAs. There was any big don't know. No, I don't think so. So no. Yeah, or token 2049 or EVM compatibility. Yes. Yes, there was quite a bit of talk about like the EVM compatibility between chains, and it is very annoying because if somebody wants to push something forward, then all these other chains have to adopt it. We can't really remember specifics, but there was a lot of like talking between these chains and coming to a consensus that like that needs to be figured out. There was a panel as well with like else from interop? No. Yeah. Yeah, yeah, there was a side event with a talk on that. I didn't get to go to that one. But essentially it was like all these L2 founders talking with each other about this. Let me see. Yes. Yeah. Yeah. I'm sure actually a lot of them attended as well. And I didn't see any talks specifically myself about those. But that is a fairly large topic in the realm, like alongside these other topics. But yeah, nothing that I came across. um, ENS, yes, ENS had their Friends Day where they're doing their L2. They announced that. But do you mean like kind of like how do these L2s now provide value to Ethereum? Ah, I think I wouldn't say so. I mean, if the L2s don't really get the chance, I would say, to be able to do that at Ethereum conference. Like, it's not heavily sponsored by a specific layer 2 or anything. Just because it's more meant to be like a developer conference and not necessarily like a yes. Yeah, I mean, yeah. I would say the OP stack is still the largest. Like everybody's building on the OP stack. I think actually ENS is building on DK Sync's thing. But no, it's largely the OP stack, the Optimism, base, other L2s like that. That's probably the biggest like developer adopted L2, just because the ability to contribute to it is just really good, and also fork and create your own, and it's just very easy to work with for a lot of developers. Other L2s like ZK Sync, like they have, I think their lens is on them now, and Friends. I was actually fairly surprised that ENS would go with ZK Sync. I would have thought that they would go with OP, but yeah, that would probably be my takeaway from that. Any other questions about the event in general, or?
Did you go to any satellite events?
Satellite events, no. Oh, satellite events. Yes, I did. Yes. I wasn't sure. Yeah, I thought you meant satellite as a company. No, the Superforum event was really good. Yeah, it was pretty good. Went to the DEVCON. It was kind of okay. I don't know. Yeah, Dune, like Dune Analytics. But oh, hey. Okay, DuneCon popped up right there. Yeah, they had some new stuff. I don't know. I don't use Dune that much. A lot of companies do. I've heard some criticism now that you have to. Oh, look at that. I've heard some criticism now that like Dune, you have to pay for some queries with tokens, which is kind of weird. Yeah.
Of compute unit a month, but if you have very expensive queries, dashboard, they consume them. So
yeah,
the way around it is to create more accounts and then have them run and like refresh the query, because really like someone needs to land on it and then be like, oh, this is out of date, I'll refresh with like, the latest data. So it's not, I mean, whether they're accurately pricing the compute units is another story, but
Yeah.
it is usable as a free on the free plan still. But
Yeah.
they definitely introduce small annoyances that you're like, should I pay? I don't know.
Yeah, that's true. Yeah, one of the other side events was Unichain. It was kind of interesting. But again, like I think they definitely have a focus on interoperability and like chain abstraction and stuff, but they weren't like super vocal about it. So I don't know how it's going to turn out. It should be interesting. They're also like working with Flashbots to create this non-MEV-able sequencer thing. They're running it in TEE, which is. I don't really know, to be honest. I didn't talk to too many people there. I'm not sure. What other events were good? Yeah, he's got it. I don't even know how I check my past ones. Oh, here we go. I didn't end up going to the DeFi Renaissance. That seemed like that could be pretty interesting. Oh yeah, that's pretty sweet. Wow. Okay. I think I saw some photos of that actually. Yeah, that's pretty cool. Yeah, nothing else that that really stood out to me, to be honest. But I think what stood out to me was just the cryptography talks, which I wouldn't say there was anything necessarily super new. It's just people are starting to now build more tooling, and it's actually becoming accessible, which is kind of cool. So people can start using that, like MPC and FHE and their actual applications. But yeah.
What's the next big fork for Ethereum scheduled?
So yeah, that was in Drake's talk, I guess. I'm not sure if there's anything like too substantial for normal users coming up too soon. But the beam chain would be big when that ends up coming, which like roadmap is there but might not go to plan, as it usually kind of doesn't. But that would be decreasing the staking cap, so you could stake with 1 ETH instead of 32, and also increasing the max utilization. So that would be coming. I don't know when that's coming, but that's probably the next like biggest noticeable one for most users. Cool. Yeah, we can probably wrap it up there, I guess. Thank you guys for coming by. It's good to get it going again. We'll definitely be back next week with something for you. We don't have a POAP for this week. Normally we have a POAP at the back there. You can tap it with your phone and get it. We didn't reload that for this week, but yeah, I don't know. I don't think there's any other announcements. We'll see you next week.